Okay, so we'll come back to our video. This video will continue our topic with the graph data structures, and the next topic will be the Kruskal's algorithm. So before we'll start, then let's define what is Kruskal's algorithm. Then, so when we say Kruskal's algorithm, that is talking to used to find the same thing, minimum and maximum spanning tree for a connected weight graph because it can be applied for both minimum and maximum spanning tree. And also follows greedy approach, which finds an optimum solutions at every stage instead of focusing on a global optimum. So the greedy choice is to pick the smallest and largest weight edge that does not cause a cycle in the spanning tree. So meaning our focus here, then we have to identify or you have to sort everything what will be the minimum to maximum amount of weighted amount of trees, then afterwards what will be the from what node is the from what vertex is it and goes to what vertex for the relationship of that particular node. And we will be going to see that later on, since it's vague as for now. So we are following the specific algorithm, which we also sort all the edges from low weight to high or ascending to descending order. Or it could be vice versa if we are doing the maximum spanning tree. So it will become descending to ascending or from high to lowest weight edges value if we are doing the maximum amount or maximum spanning tree. And we also take the edge with the lowest or the largest weight and add it in the spanning tree. And if adding the edge created a cycle, so we just have to reject that edge. And you keep adding the edge until we reach all vertices, and the vertices of n, the edges will become n minus 1, where n is your vertices. So that's how we define that one. The application commonly for the Kruskal's algorithm can be used to lay out electrical wiring among these cities, and can be used to lay down land connection, and there's a lot. So that is really useful. Kruskal's algorithm is really useful then. Now let's continue with that. Let's define first with the minimum spanning tree using Kruskal's algorithm for the first example. So for the first example for that, we have here, we define everything. We need to actually define everything, class, in a step-by-step manner. So our Kruskal's algorithm, we have, since we are following, focusing to the minimum spanning tree. So in that certain case, we need to sort out from from highest to lowest order. So we have one, weight of the edge is 1, 4. This is 1. This is 4. This is 7. Then 8. Then 10 and 23. So that is sorted here in your table. And you have the vertex sort as a source as well as the vertex destination. So what will be the vertex source of the 1? The source is B and the destination is B. And for the 4, what will be the source? It will be A, it could be C. So that can be both vice versa, but here, so that we can be in the same page, much better that you will do that in also in a sorted manner. So it could be A to C, not CA, because we are, as what I've instructed, it must be sorted manner, since we are dealing this in a undirected graph. Now, for 7, what will be the address of 7? That will be B and D, so that will be BD. For 8, that will be AD, that is correct. For 10, that is A and B, that is correct. And for 23, that is CD. So that's how you will identify that one. So let's try to figure out. So the first step we identify here, the first step, you will be going to check that one if we can add this in your spanning tree, the 1. So spanning tree of B, no changes because we cannot add that because that forms a loop and that forms a cycle then. Next then, for the 4, what about for the 4A to C? So since that does not form a cycle, we can add that in your graph, A to C, that is 4, and you put check here then. As you have to keep track that as well, so that you can form only one graph, one table, I mean. So you have to draw step by step for the subgraph, but for the table, I will only request one table, and you just keep, if it is added, you put that, you mark that as check. If it is not, you can put that as wrong. Okay, next step will be 7, B to D. So that is a check because that does not form a cycle for the 7. So that is correct. Next step, 8, AD. A to D, that does not form a cycle, so we can choose that one. So that is already, all of the cycle is already right there, A, B, and D. So by the way, in our data, Kruskal's algorithm class, it doesn't, it's actually not asking that we have to visit every particular node. If you already achieve the all of the what you call this one, vertices, it's okay to stop. But of course, we have to keep track here then, as I want you to keep track everything. So the next step, or the fifth step, will be the AB that form a cycle, so we can put that no changes, and that is wrong. And for last one, 23 CD, that form a cycle, so that is wrong, the same thing. So no changes. So of course, this is our final Kruskal's algorithm right now. And you also need to make sure to calculate the minimum spanning tree about that. So I forgot to actually to put that right here. So for the minimum spanning tree of this one, for the total of that, you have to you have to put that as well. So let me put that there. So you have the Kruskal's algorithm for minimum, that is, let me define that one. Minimum is equals to um 4 plus 8. So when we're, no, 4 plus, you can actually 4 plus 7 plus 8. So when you add that one, for, that is minimum, that is not minimum. So let me just show that. So that is minimum. When we say, when we print out the minimum for that one, 4 plus 8, that is plus 7, that is 19. So if we will be going to add the 3, that is total of 19. So that is equals to 19. So your minimum spanning tree as right now will be equals to 19. So that's how you will do that in your minimum spanning tree. You also need to make sure that you was able to identify the minimum weighted total value for the Kruskal's, for your graph. So let's proceed to the second example. For your second example here then, you also need to make sure to do it step by step in that manner that there will be no mistake. So the first step that we can do that here then, so we have to identify everything, diba? So you have to identify the specific weight for that one. So that is, let me do it. 1 second. Okay, 1 second here. Let me okay. Okay. Now 1 second. I'm still working on it here. Okay. It's almost done. So for the next step for that one, you will be going to identify. So for the you have 4. So you put that here, 5, next 9, 12, 13, 15, So you put everything that you do have in there, the same process that we did earlier. So you was able to identify that already. So you also need to make sure to identify the address of each of that one. So the address of the specific 4, that is for C and D. For number 5, that is A and D. This is here. And for number 9, that is C and F. For number 12, that is A and C. For number 13, that is B and D. For number 15, that is E and F. And for number 22, that is C and E. For number 23, that is D to F. And for 34, that is D to F. So that will be how you will get the table of that one um for the weight, source, or destinations for that. So the first step, you will just be going to figure out here for the 4CD, that is checksins that will not form a cycle. For the next step, for the second step, AD, that will not form a cycle, so you can add that one. So the next step will be the 9CF, so that will not form a cycle, so you can add that one. So for the 12, that is AC. So AC will form a cycle, so we have to reject that one. No changes. For next, for now, step 5, that is 13. So that is BD. So there's no cycle, so you can add that one. And 15, that is E to F. So there's no cycle yet, so that is that can be added. For number 22, that is C to E, that will form a cycle, so you reject that one. For number 23, that is B to F, that will form a cycle, that will be rejected. For 34, that is D to F, that will form a cycle, and you have to make sure to also remove that disregard that one. So your minimum spanning tree as right now for this one is 4 plus 5 plus 9 plus 13 plus 15, that is equals to 46. So for that example, you was able to identify the minimum spanning tree. So we are done with regards to that. And if you do have any question, you can also ping me in our MS team or here, and see you next video. I will be going to also make sure to explain there how to deal with the maximum spanning tree. So that's the end.